90 degrees, 90 degrees. If I have a shape that has 90-degree angles and all the sides are the same length, it's a square. Yeah. But wait, you know as well as I do, if I go to the Earth, go on the Earth and say, oh, I'm going to start on the equator, go up to the North Pole, then move over 90 degrees and take the line of longitude down that goes right through the Gulf of Mexico and Yucatan and hit there. Oh, I've got a 90-degree angle here, a 90-degree angle here, and a 90-degree angle here. On a sphere, I can have triangles that have more than 180 degrees in them. I can cut a piece of paper on here that would be a three-sided square. Yeah, you know, I could sort of shape this down here and here, 90 degrees down here. Not sure I drew it correctly, but let's try this one. Each of the angles here are 90 degrees. Here's a 90-degree angle, here's a 90-degree angle, and here's, well, almost a 90-degree angle. Here's a three-sided square. All three sides are the same length, and all the angles are 90 degrees. A sphere, not to be confused with a ball, but a sphere has constant Gaussian curvature, which says that if I pick a point, that point there, and draw two lines through it, and choose the maximum and the minimum curvatures of those things, multiply them together, positive number times a positive number, I'll get positive. A sphere everywhere has constant positive curvature. Okay, neat. Can I get something that has constant negative curvature? Is it possible to make something that is the opposite of a sphere? Something that instead of always bulging outward is something that's always curving inward. Can I make something? And the answer is yes. I can make a pseudosphere, a fake sphere. It's funnel-shaped, it's horn-shaped, and it has the delicious property that if I pick any point at all on it, say right here, in one direction, it'll bulge inward, and the other direction, it bulges outward. I have to make a little point here that I have to pick the minimum inward going and the maximum outward going, or the maximum of either one of them. I can't just rotate this 90 degrees. I have to, or a few degrees this way, so it's like an X. I have to pick these so that in one direction it's bulging out, and the other one it's bulging in. Turns out that a pseudosphere has everywhere constant negative curvature. That means that if I multiply to get the Gaussian curvature here, where the positive going here is not very big, but the negative going is huge. And over here, the negative going curvature is kind of small, but the positive curvature along here is quite big. A pseudosphere everywhere has constant negative curvature. Let me go back for a minute. Breathe. On an ordinary Euclidean piece of paper, every triangle, if I sum the angles, I'll get 180 degrees. On a sphere, if I draw a triangle, any triangle at all I draw on it, the sum of the three angles will be always greater than 180 degrees. It's true on the globe, true on a sphere. On a pseudosphere, no matter how I draw a triangle, its angles will always sum to less than 180 degrees. They'll be pointy in an odd way. They'll come to little pointy shapes. We can take advantage of that to draw a shape that has 90-degree corners in 5 sides. Origamiist Bob Lang showed me how to do this in a paper that he wrote, and uses all sorts of hyperbolic secants and cosecants and hyperbolic functions abound on this surface. But the cool thing is, you can take a piece of paper, get it wet, wrap it around here. Everywhere has negative Gaussian curvature. By choosing my points just right, I can find that here's a 5-sided figure. 1, 2, 3, 4, 5 sides. Each of the corners is 90 degrees. 90 there, 90 there, 90 there. Well, check, keep me honest here. Let's take a piece of paper that's 90 degrees, right? Here's a 90-degree angle right there, right there. Yep, 90-degree angle there. Over here, sure enough, 90 degrees. 90 degrees. 90. 90. Here's a 5-sided figure. Catch this, a 5-sided figure. All corners are 90 degrees. And cut out of paper like this, here's a piece of paper folded to fit, shaped to fit on top of the pseudosphere. Each of these corners are 90 degrees.
That looks like a pentagon to me, though.
It's a pentagon. It's a pentagon whose corners are all 90 degrees.
So is it a pentagon or a square?
If I say, hey, a square is a shape that has equal length edges and all corners are 90 degrees, then I could claim that this is a 5-sided square.
So its edges are equal length as well?
Each of those edges is the same length. What happens if I bash it flat? Well, a nifty thing about topology says it shouldn't be possible. If I try bashing this flat, it's like taking a section of a sphere, taking a section of the globe and bashing it flat. There's not a good mapping that will preserve areas, that will preserve directions. We get into the problem of conformal mapping and non-conformal mapping and things like this. We can do this, but as I push down here, that bends out. Push down here, oh, I'll just bend over here. Oh, maybe if I push down here, oh, then it bumps up here, bumps up there. Ah, no. How about if I push this one and this one down? This one, this one, this one. I've got 5 fingers. 1, 2, 3. 1, 2, 3, 4, 5. But now it's bumping up here. I can sort of put it at a press, but it's trying to pop out the bottom of the table. You can't perfectly map a spherical or a pseudospherical surface onto a Euclidean plane. It's a problem that map makers have had for a long time, and it's a problem that shows up when you start mapping our universe, because our universe apparently seems to have something of negative curvature.
Our thanks to the Great Courses Plus for supporting this video. If there's anything you want to learn about, including mathematics, the Great Courses Plus is gonna have it. Have a look at this one, it's called Crazy Kinds of Connectedness. But it's not just mathematics, pretty much anything you want to learn about, they're gonna have loads on it. For example, mountaineering is something I'm interested in, they've got you covered there. Or how about dog training? This is a 24-part course on dog training, which I find fascinating and I especially love because, have a look, Lulu. This dog here is called Lulu. My dog's called Lulu. But it's not all about dog training, seriously, you name it, they've got it, and it's going to be taught by world-class experts from institutions and universities all across the globe. Now if you go to thegreatcoursesplus.com/numberphile, there's also a link in the description, you can check it out and do a free trial. Access to everything. I think it's something like 10,000 videos. You've got it. Our thanks to the Great Courses Plus for supporting this video.